right, ladies and gentlemen, welcome back to another exciting edition of How Do I Do This Anyways? Today's topic of conversation, you guys are supposed to be measuring the displacement of how high your follower rod ends up going for the turning of the crank. Okay? Now, if you haven't already completed putting this thing in there, and when you turn the handle, it doesn't bounce up and down like mine is, or at least follow your cam, whatever shape it is, then you need to go back and follow the other videos. If you don't have this work plane, this horizontal work plane, you need to add that horizontal work plane right here. So go back and watch the other videos and do so, or, turn the visibility off, put an axis in, add the work plane, turn the visibility of the crank back on, and then continue on your day. All right, let's do this nice and easy. You could look at this thing and be all like, I think that's ish 45, I think that's ish 90, or you can do this like mathematically. To do that, we're going to create a constraint that is an angular constraint. Okay, and that angular constraint is going to be like that. Click on this one, directed angle, because we're going to direct an angle. And we want that constraint to be between this work plane. Come on. Getting the work plane to highlight is sometimes the most difficult part. That work plane and the work plane of the handle. You can either use this work plane of the handle, you can use one of the work planes in the axle. It doesn't matter. I'm going to click the handle work plane. Now I'm going to click apply because it clicked and it sounds like it's right. Now, what you're going to notice is that when I click cancel on this, I can no longer turn the handle. That doesn't mean that it's broken. If I want to turn the handle, then that means I need to find the constraint that is between the automata box and the axle sub-assembly. You see this angle 1? That's going to be what drives it. So if I want to just freehand move it, I can suppress that constraint and I can move the thing, okay? And the thingy will still bounce up and down. Now, right now, I'm just a little bit frustrated because this is so far off screen. So I'm going to double click on that follower rod. And you know how I gave you 3 follower rods? I'm going to edit this extrusion to be shorter. Let's just call it 3. Perfect. You see, in your automata, you're going to be allowed to customize the length of your follower rod. Plus, this makes it much easier for you to actually measure that displacement. Okay. So what we are going to be doing, I'm going to go ahead and unsuppress this thing. It's going to go back to 0. And I need to figure out my angle increments. So I have a hexagon, meaning that each little turn of this thing is 60 degrees. I'm going to go ahead and just say that I want to do 30-degree increments. So I'm going to make a chart with 0, 30, 60, basically all the way through 360 degrees. 120, 150, etc., etc. Now, I'm going to also use my inspect tool, and I'm going to measure the distance between this surface and that surface. You see how it says 1.984? I'm going to record that for my 0 degrees. 1.984. Then click done, and I'm going to drive my angle to 30 degrees. And my rod went up some. So now I'm going to measure that again. All right, now it says 2.099. Done. Confused it. Click too much. So that's what you're going to do. And you're going to go and you're going to record the distances up that it goes, and you're going to make a nice little graph of it in the following videos. Now, the nice thing about this angle constraint is that we will later on be able to drive that constraint. Okay. We'll do that later. Okay. So either way, don't forget, unsuppress it, or I'm sorry, suppress it when you want to go back to normal and just be able to turn the handle. Follow the videos later for your instructions on how to graph and chart this data. Hopefully this helps. Take care.